Speedier than the surface of space-time, it can remain mindful of it, and it'll basically tear. I'm terrified by this. At this point, our night sky is changing rapidly, and in a matter of numerous years, if not sooner, it might end up being completely unrecognizable. Cosmologists are sounding the alarm. Experts like Neil deGrasse Tyson have actually confirmed the inevitable impact of Polaris, and the story behind it is extremely surprising. Polaris, known as the North Star, has for some time been a steady presence in our night sky, filling in as an urgent reference point for stargazers, navigators, and space specialists. In any case, this could soon change, altering our night sky and cosmic assessments. We should dive into the importance of this threat and its implications for all of us. Join us as we reveal the story of Polaris as it draws near to its end. For a long time, Polaris has guided mariners and stargazers alike, standing firm as a guiding light. Its determined presence in the night sky has been essential for navigation. However, this stability may soon be disrupted. In September 2023, an exploration paper presented by the respected Royal Astronomical Society cast doubt on the fate of this heavenly light. Polaris is close to the unstable edge of exploding, potentially dissipating from the night sky permanently. Before we explore the consequences of this explosion, we ought to learn more about Polaris. Otherwise known as the North Star or Pole Star, Polaris is special because of its closeness to the celestial North Pole. Situated directly above Earth's North Pole, it appears almost fixed in the northern sky and is located in the constellation Ursa Minor, or the Little Dipper. Polaris shines as a moderately stunning yellow-white supergiant star, a part larger and brighter than our Sun. It's not a solitary star, however, it's part of a complex triple star system, with Polaris A and Polaris B forming a binary pair while Polaris B orbits them. The interactions between these stars create gravitational forces that shape their orbits and affect their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the specific mechanisms behind these interactions remain tangled. Polaris is located around 323 light-years from Earth, meaning the light we see from it today started its journey quite a while ago. Consequently, if Polaris were to somehow explode now, we wouldn't see it until more than 300 years later. It's even possible that Polaris has already exploded, and we are yet to notice the light from that event. Throughout history, the North Star has held significant cultural, navigational, and symbolic importance. Its steadiness and fixed position made it an invaluable guide for ancient sailors, helping them navigate across seas and lands. Symbolically, Polaris represented steadfastness and direction, remaining unwavering amidst the ever-changing night sky. For astronomers, Polaris served as a critical reference point, aiding in the study of stellar movements and variable stars. As a Cepheid variable star, its occasional variations in brightness have provided crucial insights into stellar properties and the nature of variable stars. This characteristic also played a vital role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, making it easier for us to anticipate its behavior. However, recently, Polaris has wandered from this usual behavior. This anomaly in its pulsation cycle has puzzled astronomers, prompting a closer investigation of this curious irregularity. Rather than following its expected pattern, Polaris has started displaying erratic patterns of dimming, raising concerns among scientists that the star may be nearing the end of its life. This aligns with behaviors commonly observed in stars nearing the end of their life cycles. The gradual expansion of Polaris' pulsation period, which was once constant, can be attributed to interactions within its star system. We've seen an annual increase in the pulsation length of 4.5 seconds, which may seem minor but hold significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these changes in its atmospheric conditions, directly impacting its pulsation patterns. Others are more concerned that it is near the critical edge of exploding. The similarities between Polaris' behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex abnormalities in their brightness, raising concerns about a potential explosion, as stars in their twilight state often display such anomalies before reaching the end of their life cycles. NASA has expressed heightened concern about Betelgeuse. However, formal attention has not yet been directed toward Polaris. As a Cepheid variable star approaches the end of its life cycle, it undergoes several stages, including the primary stage, the red giant stage, and finally, the supernova explosion. Considering Polaris' irregular pulsations, scientists predict it has entered the stages of helium exhaustion, typical of giant stars nearing their end. These irregularities in Polaris' behavior align with patterns characteristic of stars in their twilight stages. However, convincing signs of its impending supernova remain unclear. Astronomers are persistently monitoring these anomalies to understand Polaris' fate. If Polaris somehow undergoes a supernova explosion, it would likely be a colossal event in our sky, potentially overshadowing the Moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance could dramatically alter our view of prominent star constellations, like the Big Dipper or Ursa Major, of which Polaris is a part. Rest assured, Earth would almost certainly be entirely safe, regardless of whether Polaris were to explode, given its mass and distance from us. While a Polaris explosion may not be as visually stunning as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. Astronomers and observatories would undoubtedly take notice, sparking interest within the academic community and among stargazers. However, the impact on Earth's environment or ecological systems would be less significant compared to a nearer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? We should clarify one thing: while giant stars typically end their lives with a supernova explosion, this is unlikely to be the case with Polaris. When a large star goes supernova, a massive explosion occurs within it, marking the final catastrophic stage in its life. This process involves a complete collapse of the core, triggering a violent shock wave that causes the star to explode. However, Polaris is not massive enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not result in a supernova but rather a peaceful end as it evolves into a small, extremely dense stellar remnant. A white dwarf is the leftover core of a low or medium mass star that has exhausted its nuclear fuel. It's incredibly dense, about the size of Earth yet as massive as the Sun. When this happens, we will no longer see its remnants from our planet as we see the star today. By studying these past supernovae, astronomers can gain a deeper understanding of how stars evolve and what ultimately happens as they reach the end of their life cycles. The case of Polaris remains particularly intriguing due to its erratic behavior and status as a Cepheid variable star, making it an essential point of reference in astronomical research. If Polaris were to disappear from the night sky, it would mark a significant shift in human history. For centuries, civilizations have relied on the North Star for navigation and orientation, using it as a fixed point in the heavens. Its absence would not only change the appearance of the night sky but also alter our perception of celestial constancy. However, while Polaris may not be visible forever, its legacy will endure through the vast amount of scientific knowledge it has provided. Studying its pulsations, brightness variations, and potential transformation into a white dwarf offers astronomers invaluable insights into the nature of stellar evolution. The eventual fading of Polaris also raises questions about the long-term fate of other key stars in our sky. Betelgeuse, for example, has exhibited similar instability, leading some scientists to speculate that it could explode in a dramatic supernova within the next 100,000 years. Other stars, like Vega and Sirius, will also evolve over millions of years, altering the constellations we recognize today. Despite these cosmic changes, humanity's ability to adapt and learn from the universe remains steadfast. Technological advancements, such as powerful space telescopes and deep space probes, continue to push the boundaries of our understanding. Even as stars like Polaris fade from view, new discoveries will take their place, offering fresh insights into the life and death of celestial bodies. In the end, the story of Polaris is a testament to the ever-changing nature of the universe. While it has guided travelers, astronomers, and dreamers for centuries, its eventual transformation serves as a reminder that nothing in the cosmos is truly permanent. As we continue to study and observe the stars, we gain a greater appreciation for the vast and dynamic universe we inhabit. For now, Polaris still shines brightly in our night sky, a beacon of stability in an ever-shifting cosmic landscape. But one day, perhaps centuries or millennia from now, the North Star may be gone, replaced by another guiding light, waiting to lead future generations across the expanse of space and time. Understanding the possible outcomes of Polaris's explosion is crucial. For example, SN 1054 led to the creation of the Crab Nebula, a cloud that continues to expand and produce radiation across various frequencies, offering astronomers a rich field for study. Moreover, SN 1987A, observed in the Large Magellanic Cloud, provided insights into the patterns of nucleosynthesis and the mechanisms of supernova remnants, including phenomena such as the formation of nebulae, the release of enormous beams, and changes in glow. These findings can shed light on Polaris' unique characteristics. The formation of nebulae like the Crab Nebula results from the release of material during a supernova explosion, which then interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Additionally, the release of massive beams and high-energy particles, rapidly propelled by supernova shock waves, has implications for astrophysical processes and cosmic radiation conditions. To make a definitive comparison, scientists are evaluating differences in the large-scale production and speed of ejected materials between Polaris' expected explosion and other observed events. This includes studying the light curves, spectra, and remnants of these events and extrapolating similar characteristics for Polaris' expected explosion, assessing whether it may lead to the formation of nebulae or significant stellar distributions. This research improves our understanding of its potential outcomes. Another important area of study involves examining the pulsational variability of stars approaching their end stages and comparing Polaris against other supernova progenitors. This overall analysis can help measure similarities or deviations and provide insights into the explosion mechanism. Pulsational variations in stars nearing the end of their lives may indicate internal instabilities or impending catastrophic events, offering clues to the developmental processes leading to supernova explosions. Despite careful observations and extensive research, space experts remain baffled by the anomalies seen in Polaris' behavior. Unraveling the unique conditions driving these anomalies holds the key to advancing our understanding of stellar evolution. Understanding the factors responsible for Polaris' erratic pulsations requires interdisciplinary collaboration, as well as the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a significant reference point in the night sky raises fundamental questions for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of cosmic evaluations. The absence of Polaris could also impact navigation systems and cultural practices based on celestial landmarks, highlighting the significance of this celestial event. The mysterious behavior exhibited by Polaris underscores the need for deeper investigations and dedicated research efforts. Astronomers must grapple with the complexities surrounding its irregular pulsations and provide meaningful explanations. Recognizing the importance of advancing our understanding of celestial complexities, the fate of Polaris remains uncertain, and only time will reveal its true nature. Still, the quest for knowledge and understanding in the face of immense uncertainty is a testament to humanity's enduring curiosity in unraveling the mysteries of the universe. The implications of Polaris' potential demise stretch beyond simple astronomical interest. They touch on the very fabric of how humanity perceives its place in the universe. Since ancient times, celestial bodies have served as markers of time and navigation, guiding explorers across uncharted waters and lands. The loss of Polaris wouldn't just disrupt traditional navigation methods but could also have sweeping implications for cultural myths and symbolism tied to the North Star. In various cultures, Polaris has been central to folklore and spirituality. For instance, Native American tribes often saw Polaris as a guiding light in their stories, symbolizing hope and perseverance. Likewise, the ancient Egyptians used the North Star in their architectural plans, aligning pyramids with its position above. The disappearance of such a prominent star could alter cultural narratives and the framework of human experience related to navigation and direction. Additionally, the academic community stands to face significant challenges if Polaris were to vanish. Astronomical measurements and observations heavily rely on established reference points. Polaris's role as a steady guide has facilitated the calibration of instruments and models used to study distant worlds, star movements, and even the expansion of the universe. Its sudden absence would require recalibrating many of these systems, potentially leading to discrepancies in measurements and interpretations of celestial phenomena. As astronomers shift their focus to observing Polaris more closely, new observational advancements are being developed. Progress in spectroscopy and photometry enables scientists to examine light emitted by stars in unprecedented detail. These tools help identify minute changes in brightness, which are crucial for understanding the mechanisms driving celestial behavior. As experts gather more data, they aim to refine their models of stellar evolution, particularly concerning stars in the later stages of their life cycles. The study of other similar stars, such as Cepheids and red giants, offers insights that could prove valuable. For example, astronomers are observing factors like the period-luminosity relationship, which aids in measuring distances across the universe. By comparing these stars' behaviors with those of Polaris, researchers hope to gain a clearer understanding of stellar dynamics and evolution, further enhancing their knowledge of the design of our universe. Moreover, as the search for exoplanets intensifies, the study of Polaris and its companions becomes increasingly significant. Understanding the characteristics of stars and triple systems can provide valuable insights into the formation and habitability of planets orbiting them. Astronomers are keenly interested in how such stars affect their surroundings, potentially influencing the conditions under which planets form and evolve. As Polaris's behavior continues to be scrutinized, astronomers are also considering the possibility of its eventual supernova explosion or gradual dimming. If Polaris were to explode, the event would offer an unprecedented opportunity to study the final stages of a Cepheid variable star in real time. A supernova of this magnitude, occurring within our cosmic neighborhood, would be one of the most observed astronomical events in history, providing a wealth of data for astrophysicists studying stellar deaths. Alternatively, if Polaris were to experience a more gradual transformation, slowly fading over centuries, it would challenge existing models of stellar evolution. This scenario would raise questions about whether Polaris is undergoing an unusual form of instability or if it represents a transitional phase between different types of variable stars. Such an outcome would necessitate revisions in our understanding of stellar life cycles, particularly for Cepheid variables, which serve as critical cosmic distance markers. Beyond scientific implications, the potential loss or transformation of Polaris could have profound effects on human culture. Throughout history, Polaris has served as a symbol of constancy, guidance, and direction. Its presence in the night sky has shaped mythology, navigation, and even artistic inspiration. If it were to vanish or significantly change, societies that have long relied on it, whether for practical or symbolic reasons, would need to adapt. In modern times, advancements in technology have reduced our dependence on celestial navigation, but Polaris remains an essential tool for amateur astronomers, adventurers, and those who appreciate the poetic connection between the cosmos and human existence. Its potential disappearance would serve as a reminder of the ever-changing nature of the universe, reinforcing the idea that even the most seemingly permanent celestial objects are subject to transformation and decay. As observational techniques continue to improve, astronomers are eager to determine whether Polaris's unusual fluctuations are a precursor to an imminent event or part of a long-term cycle that has yet to be fully understood. The application of high-resolution space telescopes and new-generation spectrometers will allow for deeper analysis, offering insights into its internal structure, pulsation patterns, and the interactions occurring within its stellar system. While Polaris's fate remains uncertain, one thing is clear: its story is far from over. Whether it continues to shine as a steadfast beacon in the night sky or undergoes a dramatic transformation, its impact on science, culture, and human understanding will endure. As researchers strive to decode its mysteries, Polaris reminds us that the cosmos is an ever-evolving tapestry of wonders, constantly inviting us to explore, question, and discover.